Hey guys, welcome back. Today is day 38, and today we're going to talk about solving systems of inequalities. So, like a system of equations, now a system of inequalities does consist of two or more linear inequalities. Okay, we're just going to be dealing with two this year. Okay, they're two linear inequalities with the same variables. So, a graph of a system of linear inequalities is the graph of all solutions of the system. And the area where the shading overlaps will represent all solutions of the system. Okay, so something to remember when dealing with inequalities, that when we multiply or divide by a negative, we need to flip the inequality symbol. Okay, so let's look at some examples, all right, in our steps. All right, so our step will be first to graph each inequality. We're going to use a dashed line, okay, for anything that is less than or greater than, and we're going to use a solid line, okay, when it has less than or equal to or greater than or equal to. Now, the second area is the area where the graphs overlap will represent the solution. Okay, so let's start out pretty easy. The first equation, our slope is going to be -1 and our y-intercept is going to be -2. Notice we're already in slope-intercept form, okay? So that's important. That's a little bit easier. You always have to start out and put it into slope-intercept form. When you go to graph, you start at the y-intercept of -2. And in this case, our slope is going to be a -1, so we're going to go up 1 to the left. Okay, we keep doing this. So we should be pretty good at graphing lines now. We notice it's just a greater than symbol, so it's going to be a dashed or a dotted line. Okay, and now to shade it, all right, just when we did one inequality, we look at the shading, we plug in a value for any ordered, an ordered pair. I'm going to use 0, 0 as my test case. So I'm going to put in 0, 0, and when I do that, we've got 0 is greater than 0 minus 2. Okay, is that a true or a false statement? It is true because 0 is greater than -2. So because it's true, we're going to shade everything above the line. Okay, so we're going to come over here and shade everything above the line there. Okay, all right, so there's the shading for the first inequality. Now let's do the shading for the second inequality, or figure it out. So our slope in the second is going to be 3 and the y-intercept is going to be 5. Okay, because we notice we're in slope-intercept form. So to graph it, we start at the y-intercept of 5 and our slope is 3. So we're going to go down 3 and to the left 1. That gives us a slope of +3. All right, we notice it is less than or equal to, so in this case we have a solid line. Whoops. Okay, a little shaky there. All right, now we're going to test our point 0, 0 again by plugging it in. So we have 0 is less than or equal to 3 times 0 plus 5. 0 is less than or equal to 5. So that's going to be a true statement. All right, because it's true, we're going to shade to the right of the line here where 0, 0 is. So let's pick a different color so we can kind of see that. So we're going to shade here. Okay, so notice, okay, we're going to look at the overlapping region, the area where we have yellow and pink, and this is going to be our solution area. Okay, all right, so again, you can put these both into Desmos and check it out to compare. All right, that's always a good idea to check your work. But let's try the second one. If you want, you can pause the video right now and try this one on your own. Okay, the first one, our slope, we're already in slope-intercept form, so our slope is 1. Our y-intercept is -4. So we start at -4. We're going to go a slope of 1. Okay, it is just less than, so it's going to be a dashed line. All right, and then we're going to check the point 0, 0. So we plug it in, we get 0 is less than 0 minus 4. 0 is less than -4. That's a false statement. Okay, so because that's false, that means we're going to shade the other side of the line. Okay, so we go over here and we're going to shade here. We're not going to shade on the 0, 0 side. Okay, all right, so let's look at the second equation. We're in slope-intercept form, so in the second one, our slope is going to be -1, and our y-intercept is +3. So we start here at 3, and we go down 1 and over. Okay. All right, and we notice our sign is greater than or equal to, so we're going to make a solid line like that. Okay, now we're going to test the point 0, 0. All right, we plug it in. 0 is greater than or equal to 0 plus 3. 0 is greater than or equal to 3. That's also a false statement. So that means we're going to shade the opposite side of the line here. Not where 0, 0 is. We're going to go to the other side. Okay, and when we do that, we notice our solution area is right in here. Okay, where the double overlapping region is. There's our solution. Okay. All right, so let's try number 3. Now, number 3 is not in slope-intercept form, so we're going to put it into slope-intercept form. Whoops, it should be not equal to. It's actually going to be less than negative 2x minus 3. Okay, so there's our first inequality. Our slope is negative 2. Our y-intercept is negative 3. Okay, so we start at the y-intercept of negative 3, and our slope is negative 2. So we're going to go up 2 and over 1. All right, there we go. All right, so we look at it. It's just going to be less than, so we're going to make a dashed line. Okay, and then we want to test the point 0, 0, so we plug it in, and we have 0 is less than 0 minus 3. That's going to be a false statement, okay, because 0 is not less than, so we're going to, in this case, shade the opposite side of the line of 0, where 0, 0 is. So we'll shade here. Okay, now let's look at the second inequality. We'll put it in slope-intercept form. I'm going to start out the first step. Okay, I'm going to start by subtracting 2x from both sides. So I get negative y is less than or equal to negative 2x minus 1. Now this is where you need to be careful. You're going to divide both sides by negative 1. So you're going to need to flip the sign. So you get y is greater than negative 2x plus 1. Okay, so in this case, we go to graph. Our slope is going to be 2, and our y-intercept, our b, is going to be positive 1. All right, we start at a 1. Okay, there's our y-intercept, and our slope is 2. So we're going to go up 2 and over 1. Okay, here it is. Okay, we look, it's actually greater than or equal to, so this is going to be a solid line. Okay, we're going to test the point 0, 0. 0 is greater than or equal to 0 minus 1. Less than or equal to. 0 is less than or equal to negative 1. So that's also a false statement. All right, so for that particular line, we're going to shade the opposite side. All right, when we do that, we'll pick another color. And we're going to shade this side right here. Whoops, it's a little dark. But you can see the overlapping region, or the solution would be right in here. Okay, that means any of the ordered pair in that double shaded area would be the solution. All right, so I want you to pause the video here and try this one. Okay, and then come back, put it into slope-intercept form. You get your slope, you get your y-intercept. You start at your y-intercept, you graph the slope of negative 3, so you're going to go up 3 into the left one. Okay, it is going to be a dashed line. You check the point 0, 0. And 0 is greater than negative 3, so that's true. So that means you're going to shade the side where 0, 0 is. So it's going to look like this here. Whoops, not really writing. There we go. Okay, so we're shading that side. Okay, and now the other line is actually an example of a special case. Think of Vux. So it's a vertical line. So x is going to be less than 4. We go to 4. And it's just less than, so it's a dashed line. Every value less than 4 would be to the left on the number line. So when we shade it, it's going to be here. Okay, so our double shaded area would be right in through here. There's our solution. Okay. All right, so now let's look at some graphs. All right, so here we have a graph, number 5, that shows the solution, the double shaded area. It's just kind of pulled out. We want to see if the ordered pair 0, -1 is a solution. So how to determine if it's a solution? You first plot the point on the graph. So I'm going to go to 0, -1. There's my point, okay? Is it in the overlapping shaded region? Yes, it is. So we know it's a solution, okay? Let's check out number 6. It says, is the ordered pair -3, 1 a solution? So I go to -3 and then 1, and that's not in the double shaded area, so that's going to be a no. Okay, where you have to be careful is when it lands on the line. If it lands on a solid line, then it is part of the solution, but a dashed line, it is not. Okay, so let's look at some of those examples. So if we look at 3, 0, is this a solution? It's right there on the line of the shaded region. Yes, it is. Okay, but then when we look at number 8, okay, -2, 0, actually that just kind of misses it, but even if it was on that dashed line, it would still be no. Okay, so it's not in the double shaded area. So this is the solution area that's shaded in that case. All right, so now for the following system of inequalities, we want to determine which ordered pair satisfy it. So all you have to do is plug in your x and y. All right, but it needs to be true for both to be a solution. All right, so if it's just false for one, you can move on because it's not going to be a solution. So when I plug in, these are my x's and my y's, I just plug it into the first equation first. So my y is -3 is greater than 1/2 times -1 plus 1. And now I just follow my order of operations. 1/2 plus 1. So -3 is greater than 1/2, and that's a false statement. So I can move on. So I know it's not for the A. All right, let's look at B. Plugging in our x and our y. 2 is greater than 1/2 times 1 plus 1. 2 is greater than 1/2 plus 1. 2 is greater than 1 and 1/2. That's true. So now let's move on and try the second one. Okay, our y is 2 plus 3 times 1. Is that less than 6? 2 plus 3 is less than 6. Yes, it is. So that's true. So we know that this is a solution. Okay, we do the same for C. We plug it first into the first equation. All right, so our 0 is greater than 1/2 times 2 plus 1. 0 is greater than 1 plus 1. So that's going to be a false. Okay, so we don't need to move on. And then D, let's try that one. 6 is greater than 1/2 times 4 plus 1. 6 is greater than 2 plus 1. 6 is greater than 3. So that's true. So let's move on to the second equation. Our y is 6 plus 3 times our x is 4. Okay, is that less than 6? 6 plus 12 is less than 6. No, that one is going to be a false. So it's not going to be this one. So it's just going to be B for that one. Okay, so that would be it for your notes for 38A. And then you guys can go ahead and try the homework. Bye.